Hey y'all, today we're going to be talking about solving systems by elimination. Elimination is our third and final way to solve a system of equations. And this one, just like graphing has to do with graphing, substitution has to do with substituting in, elimination has to do with eliminating a variable from our equation. So just like before, I'm going to kind of talk through the steps as we look at number one, and we'll kind of be moving back and forth from there. Okay, so the first step in elimination is we want to line up the matching variables in the equation. So on number one, we have x minus 3y equals 5 and negative x plus 5y is equal to 7. So our x's line up and our y's line up. That's our goal. So just like we've talked about with graphing, it's best to graph when both of them are solved for y equals. With substitution, it's best to use when one of the two variables or one of the two equations is solved for a variable. Elimination is best to use when you have x and y lined up or on the same side of the equation. So they all have situations where they're best. Okay, step two. In step two, something important to know about step two is we only do it if needed. Okay, so if needed, we're going to multiply one or both of the equations to make an equivalent term with one of the variables. So we only do step two if we don't have two variables that have the same value but opposite signs. So we have positive x and negative x. So those both have a value of 1 or a coefficient of 1 in front of them, and they have the opposite value of positive and negative. So we do not need to multiply these equations. We'll see an example of that, so don't worry about step two for right now. Okay, then step three, we're going to add each matching term to create a new equation and solve for the remaining variable. So this is really the key step of elimination is we're going to take these two equations and we are going to add them together. And when we add them together, what should happen is we should get one of these variables to go away, to be eliminated. So positive x plus negative x is going to be equal to 0. That's going to cancel out. Okay, negative 3y plus 5y is going to equal positive 2y. And 5 plus 7 is equal to 12. So as you can notice, we now have one variable in our new equation, and then we can solve for that variable. So 2y is equal to 12. We can divide by 2 on both sides. We get y is equal to 6. Then we can plug your answer into either equation and solve for the other variable. So now we have x minus 3y equals 5 and negative x plus 5y equals 7. I'm going to plug it into the first one because my x is positive, so it's a little easier to work with. So x minus 3 parentheses 6, because I'm replacing y for y. So minus 3 parentheses 6 is equal to 5. So that gives us x minus 18 is equal to 5. Plus 18 plus 18, and we get x is equal to 23. So as our final answer, we always write our answer as an ordered pair. And this is true for all of our system of equations. So x value is 23, y value is 6, so our final answer is 23, 6, because it's always x, y. All right, and that's elimination in a nutshell. So elimination can be really easy if the question is set up for elimination. It can be a little harder if it's not as set up. So just like we talked about, there's good times to use substitution, good times to use graphing, there's good times to use elimination. And you get to pick which of the three you want to do on any question. Okay, so if there's a preferred method, you can always just use your preferred method while we are going to practice all the different ones in class. So let's look at example 2. Example 2, we have 5x plus 2y equals 11 and 2x minus 2y equals negative 4. So first step, we want to check that everything's lined up. X, x, y, y, number, number. So we're good. Okay. Step 2, we want to go ahead and multiply if we don't have an opposite term, but we have positive 2y and negative 2y. So we do have that opposite term, so we're good. So step 3, we're going to add everything up, and we should get something to eliminate. So 5x plus 2x is equal to 7x. 2y minus 2y is equal to 0. 11 plus negative 4 is equal to 7. So we got the y's to cancel out, so we're all good there. So then from here, I want to solve for x. Divide by 7. Divide by 7. We get x is equal to 1. And then I can plug that back in. Doesn't matter which equation we plug into. I'm going to plug into the one that has positive y's. I always think it's easier to stay positive if possible. So 5 parentheses 1 plus 2y is equal to 11. So that gives us that 5 plus 2y equals 11. I can subtract 5 and subtract 5, which gives us 2y is equal to 6. Divide by 2, divide by 2. We get y is equal to 3. So that gives us x value of 1, y value of 3. So 1, 3 for our final answer. So if the problem is set up for elimination, it can be really straightforward. You don't have to do any extra work at the beginning. Let's look at example 3 though. We have x minus y is equal to 11 and y is equal to negative 2x plus 19. So this one, our first step, is everything lined up? No. So we need to move. It doesn't matter which one you move. I always think it's easiest though to get it into this x, y form like we had in example 1 and example 2. So for example 3, I want to move that x term over in my second equation. So I'm going to go ahead and move this over and say plus 2x plus 2x. So that gives us x minus y equals 11 and 2x plus y is equal to 19. Okay, so now that we have everything lined up, I check step 2. Do I have something that's going to cancel out? I do. I have negative y and positive y, so we should be good there. So I can go ahead and do step 3, add them up and get them to cancel out. Okay, so x plus 2x is 3x. Negative y plus y is 0. 11 plus 19 is 30. Then solving for x, divide by 3, and we get x is equal to 10. Now I can plug this x back into my solved equations or one of my original equations, which I already have one of them that solve for y, so I can plug it in there. So y is equal to negative 2, parentheses 10, plus 19. So y is equal to negative 20 plus 19. So y is equal to negative 1. X is 10, y is equal to negative 1. Final answer, 10 comma negative 1. So that's one where we have to work just a little bit harder because both of our equations weren't set up the way we wanted. So remember, all of these substitution, graphing, and elimination, if they're not set up right, you're going to have to work harder to use that method. So sometimes, like this one personally, example 3, probably would have been easier to do substitution if I was to just see it on a test. That was the one that it's already set up for. While example 1 and 2 were definitely set up well for elimination. So it just depends on what you prefer. Okay, let's look at example 4. So example 4, we have 3y is equal to 12x minus 9 and 8x minus 2y is equal to 6. So right off the bat, we don't have everything lined up, so I got to do that first. So I can move my 12x and my top equation over. So minus 12x minus 12x. So that gives us, for our two equations, negative 12x plus 3y is equal to negative 9. And 8x minus 2y is equal to 6. Okay, from here, I have some options. I have my x's and my y's and my numbers lined up, so we're all good there. Step 2, though, right now, am I going to get something to cancel out? Negative 12 and 8 aren't going to cancel out. 3 and negative 2 aren't going to cancel out. So I have to do that step 2. I have to multiply one or both equations by a number to get something to cancel out. So you have a lot of options. You can really pick technically any number, but you want to pick a number that's not going to make your numbers too big. Okay, obviously you want to only have to multiply one equation if possible, but you might have to multiply two. So in this case, I'm going to look at those y's because 3 and 2 are pretty close to each other. So I think I can get a number pretty small that I can multiply them both to without making my numbers too big. So between 3 and 2, their least common multiple, or the smallest number they both multiply to, is 6. So I want to make both 3y and negative 2y into 6s. So to do that,
at this time, please release students who will be leading.
So I'm going to multiply this entire first equation by 2 because 2 times 3 is going to give me 6. For my second equation, I'm going to multiply the entire second equation by 3 because 3 times negative 2 is going to give me negative 6. So both of them are going to be 6s. So as I do that, that gives me negative 24x plus 6y is equal to negative 18, and 24x minus 6y is equal to
Teachers,
18.
at this time.
So now that we have the 6 and the negative 6, which was our goal, we can move on to our second step. We can add the two equations together. And you might have just picked up on something that's about to happen. We've talked about it in notes before. So negative 24 plus 24, that's 0. Well, we didn't want the x's to cancel out, but they cancel out. 6y plus negative 6y, that's 0. Negative 18 plus 18, that's 0. So we get 0 equals 0. We did this before. If we get 0 equals 0, that means our two equations were the same, which means our answer is infinite solutions. So just a reminder, wrong color, anytime you get that 0 equals 0, so you get that basically telling you that both of the equations are the same, then that means it is infinite solutions for our answer. Okay, last but not least, number 5, we have y is equal to x plus 3, 2x minus 2y is equal to 8. Okay, so same thing, I got to move one first. So let's move these x's over in this first equation, not squares. That's not helpful. Minus x, so we get negative x plus y equals 3, and 2x minus 2y equals 8. So once again, negative x, 2x, y, negative 2y, we're not going to get it to cancel out, but this time we can just multiply one equation. We can multiply the top one by 2. So in doing that, we get negative 2x plus 2y is equal to 6, and 2x minus 2y is equal to 8 still. So now we can add across. Negative 2x plus 2x is 0. 2y plus negative 2y is 0. 6 plus 8 is 14. Okay, well, 0 equals 14. That's not true. So instead of our infinite solutions, this one is our no solutions. Because this means our two equations are parallel, which means they're never going to touch each other. Okay, y'all. That is solving by elimination. So the big thing, the time you want to really solve by elimination is when those x's and y's are lined up, and when you have one of them that's going to cancel out easier right away without having to multiply. Even if you have to multiply, sometimes it can still be a good choice, but really, it's these ones like example 1 and example 2 where solving by elimination is your number one best bet. Okay, but now you know all the different ways that you can solve systems of equations, so you can choose whichever method you want to use on any quiz or any test. All right, y'all, if you have any questions, come to tutorials or ask your teacher in class. That's a good idea too.